Okay, this is some homework help for section 10.5. Oh, I do not think I know the numbers on this. Okay, well, this one is where we're looking at three different cones that are similar to each other. And so, one of the things that I want you to realize is that when we are talking about height and perimeter, that is linear. And so, we are just going to have some value k here. Okay, we don't know what that value is, but it's just going to be k. But once we get to surface area is something squared. So, whatever the relationship is here for height and perimeter, that same relationship is going to be squared for surface area. Then once you get to volume is cubed. So kind of think about your units, like when you do the perimeter or the height of something, you are going to have inches or centimeters or meter. When you do area, you're going to have inches cubed, centimeter, or inches squared, centimeters squared, meters squared. And then when you get to volume, you're going to have cube. So it'd be centimeters cubed, inches cubed, or something along those lines. So the first thing that we're going to do for height is we're going to look at the relationship right here between these two. So I've got 8 times 3, and that's what gives me 24. So the relationship between cone 1 and cone 2 at this level, at the k level or the linear level, is 3. So this number times 3 gives me 24. So here, this is the larger cone, and so we're going to go the other way. So 30 divided by 3 is going to give us the perimeter of the base of that first cone. Okay, and so here the relationship, and that's what we're looking at here is the relationships. The relationship here is 8 times 3 gives me 24, and 10 times 3 gives me 30. Okay, now if we look here, we have a relationship right here. Okay, so the relationship between 30 and 15 is 1/2. Okay, so we've multiplied this by 0.5, or you can think about this as multiplying by 1/2. The other thing that you can do is you can look at this 10. Okay, 10 times 1.5, or 3 over 2, is giving us that third column. Okay, so let's do 10 times 3 over 2 is going to give us 15. So let's do 8 times 3 over 2, and 8 times 3 over 2 is going to give us 12. So this one right here is 12, and we have all of our linear stuff. Now, remember, the difference between 8 and 24 and 10 and 30 was a multiple. We multiplied times 3. But here we've got k squared. So to get from 12 to our next one, we're actually going to multiply by 3 squared. Okay? So 12 times 3 squared, that's 12 times 9. That's going to give us the lateral surface area here of that second cone. Okay, and that's because our k value is squared. So our k value between 1 and 2, okay, our k value between 1 and 2 was 3. Okay, and then our k value between 1 and 3 was 3 over 2. Okay, so now to get from our first cone, and we've got our surface area right here, to our third cone, what we're going to do is we are going to multiply times our k value, which is 3 over 2, and then we're going to square that. So what I'm doing right now is I'm going from 1 to 3. So I'm going to take this 12 and I'm going to multiply by 3 over 2 squared. Okay, so I've got 12 times 3 over 2 and all of that is squared. So that's going to be 12 times 9 over 4. These cancel right here, so I'm going to have 3 times 9, and that is going to give me 27. Okay? Now, for our volume is we're going to cube that k value. We're going to cube the k value. Now, here, we are going from 64 back this way. So the volume of this is going to be smaller than 64. Okay. Now, this value right here, going from here to here, is 1/3. So 24 to 8, 8 is 1/3 of 24. 30 to 10, 10 is 1/3 of 30. So I'm going to take 64 and I am going to multiply that times 1/3. Because I'm talking about volume, I've got to cube it. So I'm going to have 64 times 1 over 27. 3 times 3 times 3 is 27. And so the volume here is 64 over 27. Okay, now I'm going to go from here to here now. Okay, so I'm going to go from here to here now. And we know that our k value between 1 and 3 is 3 over 2. We're talking about volume, so I'm going to have to cube that. So I'm going to have 64 over 27 times 3 over 2 cubed. Okay, so then I'm going to have 64 over 27 times 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. My 27s cancel. My 8 and 64 cancel, and so I am left with 8. So the big focus that you want to think about right here. So you're looking at the relationships between these measurements, and these are linear measurements right here. Height and perimeter, those are linear. So you're just going to have some k factor. Once you identify what that k factor is, then when you start talking about surface area, you're going to square the k factor. And then when you start talking about volume, you're going to cube it. Okay? And sometimes the similar figures are a little bit more challenging to understand. So we're going to go ahead and we're going to talk about our ice cream cone. That's our other cylinder one. An ice cream soda glass is shaped like a cone of height 14 inches. So that means the entire height here is 14 inches. It has a capacity of 32 fluid ounces when filled to the rim. So that would be absolutely to the very top. We have 32 fluid ounces. Okay, use the similarity principle to answer the following questions using the fact that the cone of liquid is similar to the cone of the entire region of the glass. So we're only going to fill the glass up to here or here, and then we're going to be looking at it. So remember, when we're talking about volume, okay, we're going to have some k value, and it's going to be cubed. And the reason I know it's a cubed value is because it's volume. And volume is measured in cubic centimeters, cubic meters. So we're talking about volume. So how high is the soda in the glass when it contains 4 fluid ounces? So what we're going to do is we are going to take this value here, 32 fluid ounces. Okay, and we are going to multiply that times our k value cubed. Now, we don't know what our k value is. Okay, and then we're going to set it equal to these 4 ounces right here. Okay, so then we're going to divide both sides by 32. So I have k cubed equals 4 over 32. Okay, I can simplify that to 1 over 8. And then the cubed root of 1 over 8 is 1/2. And the reason for that is 2 times 2 times 2 equals 8. So the cubed root of that is 2. And that's where I get my 2 from right here. Okay, now this is just telling me my K value. That's all that's telling me right now. Okay, that's all that's telling me. So in this situation, I'm going to take this 1/2, and then we're talking about the height. So I have half of my height. When I have 4 fluid ounces in here, I'm only talking about half of my height. Okay, and so half of my height, so I'm going to have 14 times 1/2, and that's going to give me the height of 7. And so it is 7 inches high when it has 4 fluid ounces. And think about that, because, you know, we've got this cone shape right here. Got a cone shape, and much less is here. Much less. Like and then if I fill it up all the way up here, we've got much more, but this is a much smaller area. The higher we go, the area increases, but this is a significantly smaller area right there. Okay, so the answer to this right here is 7 inches. Okay, part B, how much soda is in the glass when it's filled to a level 5 inches below the rim? 5 inches below the rim. Okay, now we're going to have a different K value here. So we are going to find this K value. Let me erase this, because now we're talking about height. We're not talking about anything cubed. How much soda is in the glass when it's filled to a level 5 inches below the rim? So we're only talking about the height. So we know that the glass is 14 inches high, and we're talking about 5 inches below that. So we're going to have 9. So 14 times some K value that we don't know yet is going to be equal to 9. Now, again, why are we just using K? And that's because we're talking about height, and height is linear. Here it was K cubed because we were talking about volume. Okay? So our K value here is going to be 9 over 14. Okay, and now we are going to plug that in to our volume to find out how much soda is in the glass. So our volume is going to be K cubed times our 32, and I'm getting this 32 from right here, 32, okay. This K factor is cubed now because we've gone from height, which is linear, to volume, which is cubic. So now I've got V equals 9 over 14 cubed. And this one we're going to stick into our calculator. Now I want to be sure that you're plugging into your calculator correctly. So what you want to do is you want to have parentheses, 9 divided by 14 on your calculator, close that parentheses, and you've got to have it in parentheses because we've got a fraction there, caret top, raised to the 3rd power. Okay, then we're going to multiply by 32. Let's go ahead and round to the nearest tenth, and so you're going to have 8.5 fluid ounces. Okay. So sometimes this one's a little bit more challenging. It's not terrible, but it's a little bit more challenging trying to visualize all that. Okay, now let's move on to the next one. Okay, here we have a square right rectangular pyramid. So what we've got right here is this is a square, okay, and then this right here if you fold those up, you get a pyramid. So you've got a pyramid with a base that's a square, and then it kind of, that's what the pyramid looks like. And I do not do a great job drawing pyramids. Let me see if I can. So we have a square, and then we have, yeah, I don't do a great job with this. So, and then they all kind of go to that point right there. Okay. Now, the first thing that we've got to find is our slant. Our slant. So if I had my pyramid, let me see if I can find a pyramid somewhere. It does not look like I can. Yeah, I can't bring pyramids in here. Okay, but you know, you've got your pyramid, you know, and this one's got a square base. I think I need to take a class on how to draw a pyramid. I keep drawing it and it doesn't look any better. Okay, there we go. So what I want us to look at is this right here on the outside. Now, we're not talking about the height of the pyramid. The height of the pyramid kind of goes in here and hits the base right in the middle. I'm talking about this slant height right here. And this slant height would be represented right here. Okay, so we're talking on the outside of the pyramid. So if you can imagine sitting at the top of the pyramid and then sliding down it, your slant height is going to be on the outside of that. And that's what we're talking about right here, that we want to know this slant height. So the way that we're going to find that slant height is represented by this right here. Okay, now, so what we've created is a right triangle. So this distance right here is 35. This distance right here is going to be half of this 42. So it's going to be 21. So what we have is a right triangle. This perpendicular part right here, this is going to be our slant height. Right here. Here's our right triangle. This is 21 and this is 35. Okay? And we're all talking about centimeters right here. So we can use the Pythagorean theorem. Now you got to be careful with the Pythagorean theorem because this is my hypotenuse right here. That's my C value. So you got to be careful with that. So we're going to have some A value that we don't know yet. Then we've got our B value, which is 21, and then our C value, which is 35. Okay, so my A squared is going to be 35 squared minus 21 squared. And so then A is going to be the square root of that right there. Okay, now I tend to put those in my calculator separately, so I want you to be careful with that. You definitely want to practice putting that in your calculator, but when you compute that, you end up with 28 centimeters. Okay, so that is this outside slant. If I was sliding down the pyramid right here at a perpendicular to this base and hit it right in the middle, that's what my slant height would be. So I've got 28 centimeters. Okay. What is the lateral surface area of the pyramid? So remember, lateral surface area of the triangle pyramid doesn't include the base. So it is this part right here. This plus this plus this plus this. Okay. Now, most of the problems on your midterm will have formulas given, but you are welcome to have a formula sheet for your midterm. You don't have to memorize all these. Definitely too many things to memorize. So let me erase this because now we're talking about the lateral surface area. You also have a formula for the lateral surface area. And so it is going to be 1/2 the perimeter. Okay, lateral surface area is going to be 1/2 the perimeter of your base. So the perimeter of our base is this square right here times my slant height. And we just figured that out. So my lateral surface area is going to be 1/2. The perimeter of this is 42 times 4. 42 plus 42 plus 42 plus 42. That's the perimeter of that square. So it's going to be 168. And then we know our slant height. It's going to be 28. Now, we're talking about surface area now. So we are going to have centimeters squared. Okay? 1/2 times 168 times 28. When you put that in your calculator, you should get 2,352 centimeters squared. Okay? So that is our lateral surface area right there, 2,352 centimeters squared. Okay, now we are going to find the height of the pyramid. Now, different than the slant height. Now, we just talked about the slant height. Now, the height of the pyramid. So, I know we're already laughing at how I draw pyramids. So, if I have a pyramid right here, let's see, and then I have something that looks like this. Okay. Now, the slant height would be if I was sitting up here and I slid down the pyramid, on the outside of the pyramid, and I slid down it. That's the slant height. The height of the pyramid is going to go down inside, and it's going to make a right angle with the middle of the base of this square. Okay? So if the slant height is me sliding off the side, on the outside, the height of the pyramid is me dropping a rope. So I'm standing up here and I'm dropping a rope and I slide down that rope and I'm inside the pyramid. So that's what I want you to notice. I want you to notice the difference between those. So I'm going to create another right triangle. So this is the distance I'm looking for. And then my slant height is going to play a role in that. So I'm creating this triangle. So this distance right here, that's going to represent the height of my pyramid. This distance right here is going to represent the slant height. Okay, this is my slant right here. Now, how do I find this distance? We know that all the way across is 42 centimeters. So if the height, if I hit it right in the middle of that, we know that that's going to be 21 centimeters. So it's going to be half of the length of my square. That's the base. Okay? Now my slant is 28. So again, you got to be careful with what you're looking for right here. Okay? You got to be careful with that. So now we've got a right triangle, and we're looking for this side right here. Okay, so how do we do that? So a squared can be our 21. Okay, our b squared we don't know, and our c squared is going to be that hypotenuse, or our slant height. So b squared is going to be 28 squared minus 21 squared. And the square root of that is going to be our b value. And again, all of these are positive values because we're talking about distance. Okay, so you're going to plug that in your calculator. Be careful with your keystrokes in that calculator. And when you do that, you're going to end up with 18.52 centimeters. And again, we're still talking about centimeters. We're not talking about anything squared, because for this, we're talking about a height. Now, when we're talking about lateral surface area, that was squared. So we had centimeters squared. But the height of the pyramid is 18.52 centimeters, because that's the height. And then the last thing that we have to figure out is our volume. And our volume of this pyramid, and lots of times I think volume is easier to think about than surface area. I think surface area is sometimes difficult. But volume for this is going to be 1/3. Capital B means the area of the base of this perimeter, this pyramid. Okay, so that's the area of base. Okay, and the way that we're going to find the area of that base is 42 times 42. So this part right here, this is the area of our base right here, and that's 42 times 42. And 42 times 42 is, so we have 1/3. I'm going to go ahead and write 42 times 42. And then we also know the height of our pyramid is 18.52. Okay, 42 times 42 is 1,764. Okay, and then we're going to multiply that times 18.52. And when we do that, our volume is approximately, because we're rounding, 10,889.76 centimeters cubed, because we're back to volume, and so we are cubing that unit. Okay. Okay, last one for today. Find the surface area and volume of the solids. Now we've got two different solids that we're going to look at, and we're going to start with surface area. And again, oftentimes I think that surface area is a little bit more difficult than volume. So basically what we have is we have a cylinder, and here's my cylinder right here. Here's my cylinder. And then I've got half of a sphere right here, and then I've got half of a sphere right here. Now, when we start talking about the surface area of a cylinder, if I was only talking about a cylinder, the surface area would be 2 pi r times h of the cylinder plus 2 pi r squared. Now, this part right here, the surface area of a cylinder, is this rectangle that the middle part of the cylinder makes. This part right here is the top and the bottom. The top and the bottom of the cylinder. But we don't need that in this picture right here because we've got a sphere at the top and the bottom. So the only part of the surface area of a cylinder that I want is this right here. I don't want that part. Okay? So I've got the surface area of this figure is going to be 2 pi r times h. Then I want the surface area of a sphere. Okay, so the surface area of a sphere is 4 pi r squared. Okay, so the surface area of a sphere is going to cover this part and this part. So now I think we have all of our information. So I have the surface area equals 2 pi. Okay, my r, we don't know my r, but we know that my diameter is 10. So if my diameter is 10 feet, then my radius is 5 feet. The height of my cylinder is 16. And then we've got 4 pi, and then my r is squared. Now again, you got to be careful putting that into your calculator. But when you do put it into your calculator, and we're going to go ahead and round to the nearest whole number, and I would go ahead and do it separately, to be honest. And instead of don't put in 3.14 for that. Put in the pi value on your calculator. So the surface area for this is going to be 817 feet squared, because we're talking about surface area. Okay. Now, the next part of this is we need to find the volume. And again, I think the volume is not as difficult as finding the surface area. So the volume of a sphere is going to be 4 over 3 pi r cubed. That's the volume of a sphere. Then we've got the volume of our cylinder, which again, you can have a formula sheet, but many of the formulas are also provided for you. So I have pi r squared h. Okay, so then our volume is going to be 4/3 times pi. Our r value is 5, and then we're going to cube that r value plus pi times 5 squared plus our h, which is 16. Again, you want to be super careful. We're going to round to the nearest whole number, and when you stick that in your calculator and round, you're going to get 1780. So 1780 feet cubed. Okay, you just kind of have to think through them and break those apart one by one. And I think we've got one more figure to look at. We're going to do all the same things with that. Okay, so here what we have is we have a cone. So what we're looking at here is a cone, and it's on top of a cylinder. And so we want to break this down as well. Okay, so a cone and, or whoops, I did that backwards. A cone and a cylinder. So first thing that we've got to figure out is this surface area. Okay, so we're going to have, just like we did on the one before, we need the surface area of the inside of this cylinder. And so we'd already talked about that, what that's going to be. And the surface area of not the top and the bottom, we're just talking about the round part, is going to be 2 pi RH. Yeah, that's the 2 pi RH. Okay. And so that is going to give us it. And when you, if you were to cut this right here and lay this out, you would get a rectangle. Okay, and it would be the height, and then the 2 pi r is the circumference of the circle. So that's that first part right there. Now we need the surface area of the very bottom. The very, very bottom. And you can also think of that as the surface area of the bottom of this pyramid. So it doesn't matter which way you think about it. Either way is completely fine. But we only need to account for one of those circles. We don't need to account for the circle up here and the circle down here. So I'm going to have pi r, just pi r squared right here. Okay, pi r squared. And that's accounting for just this bottom. Now, usually for a cylinder, for the surface area of a cylinder, you have 2 pi r squared, but we only want one of them. Now, the last thing that we need to think about is the lateral surface area of our, and it's not a pyramid, it's a cone, the lateral surface area of this cone. And we get that by pi r times the slant. Okay? Pi r times the slant. So r is our radius, s is the slant, and h is the height. And I think we have all that. So we've got the surface area of this figure is going to be 2 pi. Our r is 5, and our h is 13. Then we have, let me make sure I did that right. Yes, I did. Whoops. Oh, I just wrote it in a different order. Okay, and then I have pi times r squared, so that's going to be 5 squared. And then we have pi times our radius times our slant. Okay. Now, some students like to do it in each individual section, and that's completely fine. You can put this all in your calculator at the same time, but I would double check it. Make sure you're doing it exactly the way that you want to. Okay, so for our surface area here, we're going to have 597 meters squared, and we are rounding to the nearest whole number. And it's squared because we are talking about surface area. Now, we're going to do volume in just a minute. We're not doing volume yet. We're just doing surface area. Okay. Now, last thing that we're going to do is we're going to find the area of these two. Now, we're going to have two different heights when we start finding the area. I'm actually going to go ahead and erase this so that we can just focus on this. So basically what we're finding here is we need to find the volume of this cylinder first. Okay, then we need to find the volume of the cone. So we're going to have the volume of the cylinder and the volume of the cone. Okay, now the volume of the cone is going to be 1/3 times the base of the cone times the height of the cone. Okay, so we don't know what this height is yet. Now we can figure it out because we can use the Pythagorean theorem to do it. But this has got to be the height of the cone. Now, the volume of the cylinder is going to be pi times r squared times the height of the cylinder. So I just want to make sure that you realize that there's a height of the cylinder and there's a height of the cone. Okay, now this base right here is a circle, so that is going to be pi r squared. So we're going to have the volume of the cone is 1/3, and the base is pi r squared because it's a circle. And then we're going to have the height of the cone. Okay. You can write this all in one formula if you want to, but because we've got two different heights going on, I wanted to do it separate. So we are focusing on this right triangle right here. Okay, 7 is our hypotenuse, 5 is one of the legs. So I'm going to have a squared plus 5 squared equals 7 squared. Okay, a squared is going to equal 7 squared minus 5 squared, and so a is going to be the square root of 7 squared minus 5 squared. Okay, and so our a value here is going to be approximately, and that's what those squiggly lines mean right there. They mean approximately 4.90. Okay, so the height of our cone is 4.9 meters. Okay, so now we've got enough information to solve this. So my volume is going to be pi r squared times the height of my cylinder plus 1/3 pi r squared times the height of my cone. So we have pi times 5 squared times 13, because that's the height of my cylinder, plus 1/3 pi times 5 squared times the height of my cone, which is 4.9. And then when we multiply that out, and you want to practice putting that into your calculator, it's just as important to practice doing your keystrokes on your calculator as your other stuff. So the volume is 1,149 meters cubed.